Can you hear me online? So I am already recording the video so that anybody who is not able to join, they can see it. Okay, so let us start. I see that many of you have submitted some assignment for some homework, so that is very good to see. I would like everybody to submit so that I can get some feedback. Which are the things you have understood, which you have not understood, which are the things that you have found on your own, which is very good. So there is a lot of nice ideas that you have submitted. So I'll go through them in detail and I will respond to you. But yeah, in general, one of the things which I see many students have done correctly is the theorem 1 and theorem 2, right? That we discussed. But one mistake which many students have done is if you actually, even I did only one half of theorem. You have to show that if that was part 1, but you also have to show the reverse part, right? So some of you have done it correctly, but many of you have missed that part. So go back and think again. That when you want to show that so the proof has to have 2 parts. So the part 1 is so first set. Only part 1. What will that? L is a subset of R, correct? And if I draw a Venn diagram, it looks something like this, right? Every element in L is an element of R. But there can still be some element over here, right? Some element which is in R but not in L. So what do we need to show? The reverse also, right? So what is part? If an element can happen is the both sides have to be equal. Okay. So both part 1 and part 2 are important. Some of you have missed that part. So just go back and teach more. Okay. And some of you also got that star problem. I see that many of you solved. By the way, I made one incorrect statement last time. So I actually had to go back and well. So I said that, that star operation is used again and again in all the computers and all the devices. But those who have found the answer, do you see a reason why that is not a good idea? You raise your hand. Anybody who found the answer? Full question. A union D dash extension C. Somebody submitted, right? Maybe they are online. Anushka, you submitted, right?
Yes, sir.
And there are people did submit. So I don't know. Maybe they are online. So I would say a reason why it is not a good idea to use only the star of. Yes, Ruhan also submitted. So
Excuse me, sir. Your voice is cracking a bit.
My voice. The problem is internet connection here, so I have to rely on my mobile hotspot. So that may be the reason why the audio may not be very good. But we'll have to continue once the internet restores properly. You can hear me properly. Okay. So if you remember what was the star operation, can everybody tell me again? A star is defined as
Section B complement.
and the question I gave you was what you have to find? A union B complement intersection C intersection E. So suppose you have to design some electronics to do this, and you have to use components. So there will have one component which can do union operation. So let us say that union operation requires 1 rupee. Okay, so you every time you do union of two things, you have to give me 1 rupee. Let's say complement also requires 1 rupee, and intersection also requires 1 rupee. So how many rupees will you require to do all of these things? 4 rupees, right? So in 4 rupees, you can achieve all of this operation. Okay. And that star operation, let us say that star also costs 1 rupee. So now somebody who has solved the question, can you tell me that if you use only star operation, how many rupees will you require? Anybody who has solved the question, can you see? 20, 21, 23. And one of you is either incorrect or there can be multiple solutions also. But minimum 21. I don't think you can do below 20. So you see, if you use only star operation, basically you have to use 20 stars, star, A star, B star, C star, D, for A star, B star. If you check anybody's notebook has written it, it takes 3 lines to write everything. Star I could have written it on the board also, but that will take a lot of time. So you require 20 rupees if you use only star. But if you use all of these, you can do it in 4 rupees. So that is why practically it's a good idea to use all the operators. But you can still do it. That was the idea. Okay, so just to quickly revise the most important things that we did last time. So we started with the notion of what is the set. And will we define what is the set? We said that it's an undefined object, and you understand the reason why we have to have undefined objects in mathematics, because we need some starting point. So set and membership we consider as undefined objects. Then we consider basic operations, union, intersection, complement, right? And then we also looked at some theorems using union intersection. So for example, I think one theorem was A union B intersection C and A intersection B C. We're able to simplify that. And many of you have submitted your own new theorems using these operations also. And whether there are like basic things, like what is a set union set? Take the set and take its own union, what will we get? And the same set, right? So that is big. And what is the intersection of the set with itself? That's it. Because all the elements common to both sets are the same. So these are obviously trivial things. Then maybe something else that what is the intersection of a set with its complement? Null set, because what is the complement? It is precisely all elements to the intersection which will all the common elements. There will not any such common element, right? So this will obviously be the empty set which we denoted by. So you can either denote it by this zero with a slash, or you can simply write open close bracket. It is the empty set. There is only one empty set. And then what about the union of A and its complement? It will be the universal set because it will contain every element, because every element either belongs to A or it has. So these are basic things. Then similarly, in fact, some of you submitted this also. Instead of taking union and intersection, what if I take all the unions? So the first question is, if I give you three sets, can we take the union of all of them? So, for example, suppose I have three A, B, C. What if we A union B union C? Everything like every element that is in either A or B or C. But if you think about it, union is between two sets only. So there might be two ways to compute this, right? Somebody may say, I want to compute this first, and somebody may say that I want to compute this. So depending on how you do the grouping of the brackets, will the answer change? No. Do you know what this is called? Because additional multiplication also have these properties, right? Associative property, right? So what we are saying is that union is also associative in the same way. So this is also a theorem which you can prove. Same with intersection. If you want to intersect these sets, then you can do it in either order. The answer will not change. So both union and intersection are associated. We call this associative. What else can we say? Any other basic property about the set that I have missed? That anybody can suggest. Yes. Yes. What is the complement of? What is the complement of the complement of the set? Again, obvious. So if I have A dash and dash of that, that is equal to A. So all of these are basic things, but very useful for applying in various contexts. Okay, so let's come to something more interesting. So all of this, if you have understood and you understand how to write the proper proof also based on last time's experience. So let us now combine union, intersection, and solve. So what about some of you have already found the answer to this, so I would suggest don't disclose the answer immediately. Let others also think. But these are the two new questions for us. So what about this? And I think the second one, do you recognize? It is the star operator, right? That we talked about. This is simply A star B, which I mentioned last time. So find out. Online, are you able to hear me now?
Yes, it's better, but it's a bit low.
Okay. Okay, I don't have anything in my control, but I will try to keep the voice loud.
Sir, I couldn't hear you very well before. So, are these two new questions?
You already have the answer to this?
No, sir. Hello?
Sorry, I couldn't hear you properly. Can you repeat?
Sir, I'm saying I could not hear you properly before. Did we discuss the puzzle that you gave last time, the last one?
Okay. So, having these are the questions that you do right now. You want me to repeat anything that I covered before?
Sir, did you cover the star symbol puzzle that you had given last time?
Oh yes, but I will come back to it towards the end of the lecture, so you have not missed anything.
Okay. Thank you so much.
So I hope you are going to repeat the same mistake that when you have to show to center, you have to show both sides. New thing. I but then you imagine next take off. Go to the answer. What is the first thing that you can do? Or in diagram?
For the first question, it is like everything excluding A and B, right? So how are we going to write another equation?
Sorry, anybody saying online?
Yes, sir. So for the first one, A union B complement. So it is basically everything excluding A and B. So how are we supposed to like write another equation or expression?
So if I draw the Venn diagram of the first one, it looks something like this, right? So this is the universal set. Then A union B is everything inside. I'm interested in
Yes, sir. So do we like use the set universal set for the expression also?
can use the universal set, but do you really require it? Think about it.
Okay, sir. I think I got it. Yes, sir, I got it now.
So let us try to build this. I want to reach this green portion. Somehow I have to reach it. So what can I do? Let me start with the set A. So can I take the set A? Because set A is all the elements inside that. मला त्याचं उलट हवंय ना. So what should I take instead of A? Complement. A complement. So A complement is all the elements which are not inside A. So which region is that? It is this region, right? This yellow shaded region is my A complement. Everything which is outside of A. So that is covering my green region, but it also has something extra, right? This I don't want it. So that has also sort of leaked into my required region. So I have to get rid of that extra part. But let it be. Then can I similarly think of B complement also? So if I get B complement, if I show it in a different color, which region is that? The diagram is very complicated. Let me draw two different diagrams. Maybe that is better. So let me draw a diagram for the LHS and a different diagram for RHS. Yeah. But are you able to piece it together and make a guess what the RHS can be?
Sir, it should be A complement intersection B complement.
Okay. Is everybody able to see that? So the LHS, if I draw the Venn diagram of just the LHS, it is this part. And if I take in the RHS, first try to take complement. And then I have to be complement. So the only region which is shaded by both colors, you see which region is shaded by both colors? It is the region outside this part, which I want. Everything inside this part, you see, it is only shaded pink. It is not shaded yellow. Why? Because yellow is a complement. And reverse. Everything in this part is shaded yellow, but not pink. So therefore, if I take the intersection of these two, I will only get the regions which are both yellow and pink, which is exactly what I want. But this is the visual proof. This is not the proof that I will accept as a formal written statement. This is my guess based on the Venn diagram. Now I still have to write it. So how do we start to prove this? As usual, let an element belong to the left side. I have to show that it belongs to the right hand side and vice versa. Right? So I'll give you 5 minutes to try and write that on your own. For convenience, let me call this as L and R. So X belongs to A union B whole complement. In other words, X does not belong to that set, right? X does not belong to the actual set. So if we said X cannot belong to A or B because we are taking the union. So you think X belongs to A or B, one of A or B, there will be a contradiction. So therefore, we can say X does not belong to A. So if X does not belong to A, which means that belong to A. Therefore, it has to belong to. So, this complement is a very funny operation because when you take the complement inside, it also distributes, right? The complement goes to both the set, but the sign changes. The union becomes intersection. So now what do you think will happen on the question two? Where
Sir, can I
inside you have
say?
intersection? Yes.
Yes, sir. So the expression I got for the second one will be A intersection B complement is equal to B union A complement intersection A union B complement.
But I think that will be unnecessarily complicated. We can represent the same idea using just A complement and B complement also. Think about it.
So I have another answer, can I?
I think what you are saying may also be correct, but maybe you can simplify it. So can you write part two of this now? It's okay. Okay, so question one and question two are, we should call them theorem one and theorem two now because they are proved them. So question one was there and question two is. So these both theorems together have a name. You know what it is called? Anybody? They are called the Morgan. I have to find out who this person was. I think the Morgan was mathematics. Sometimes they are also called the Morgan. And you see, there's a very nice symmetry to it. It's a union of the intersection झालं. It's a intersection with a union झालं. Almost like you can imagine that if you take the first statement and replace all the unions with intersection, you get a second statement. Like magic. Concept पण होतं. If you remember the first two problems we did last time, they also had the same property. You remember that? So what was the statement? A union B is C. We could write that. And what was the second one?
A intersection B.
And what was the answer to that?
Intersection B intersection.
That's all left. It seems that set theory comes in pairs, In superhero movies, you have the Superman and anti-Superman, or particle and anti-particle. Every statement in set theory comes with its own twin. And this principle is very easy to explain, but very hard to prove. We are not that capable of doing it today, but just observe how that is working. Everywhere you can replace the union with intersection, and you get another valid statement. Same here also. So sometimes this is called duality. Duality. Maybe you have heard this word duality somewhere else. I don't know. Have you read any physics? Sorry. Wave particle duality. Yes. If you are interested in some quantum physics, quantum mechanics, wave, light wave as a wave as well as a particle. So, right? Maybe you have heard it. This kind of duality occurs many times in nature. In fact, in geometry also there is a duality. You know the duality in geometry? Point and line. Take any statement which has point, point, point. Replace every point with line and line with point. You will get another theorem. करून बघा. So every time you think that I have studied 5 theorems, actually you have studied 10 theorems. Because every statement has a dual theorem. But actually, you know, that is not completely true in normal geometry. In normal geometry, काय होतं माहिती का? For example, take a very simple statement. If I have two distinct points, I can pass a line through it. True? But if I have two distinct lines, can I find a point on both of them? Parallel lines, no problem. But if you ignore that parallel thing for a while, then it is true. Do you see? For parallel lines, you can imagine that there is a point very far away, beyond the horizon. We sometimes call it the point line. So like we have to photo cheating you can say. But if you allow me that much cheating, then you can replace point with line and line with point, and any geometry theorem becomes a new geometry theorem. But we have to study this properly at some point. Okay. Let me come back to what we started discussing last time. Cartesian product आठवते सगळ्यांना A cross B. Okay. So if I have set A and set B, and A cross B is the set of all ordered pairs, right? So A comma B. So that A belongs to the first set and B belongs to the second set. And we took an example of an interesting cross product of natural number with itself, right? So if I take the set of natural numbers and cross with itself, I'll get the set of all pairs of natural numbers. And we took one subset of that. So what was the subset we considered? Div, right? So div is a subset of this set. And we define div as how? Div is the set of all the pairs. Then that obviously they have to be natural numbers. And P is a multiple of A, correct? And then I also ask you to do some properties about that, like A divided B, B divided C, then A divided C. But today what I want to point out to you is, so for example, what was that theorem 1 that we wrote, for example, I think if A comma B belongs to div, and B comma C belongs to div. So you know, writing all of this is very cumbersome. The way A comma B belongs to div, it's a very big statement. So just to make it simpler, we replace it with one symbol. Okay. So what is the symbol that we use? So actually we write A sin B, and when you read it, what we are supposed to read? A divides B. So this means A divides B. And implicit in that, the part if you don't say is with remainder 0. You don't say that every time, but that is understood. So what I am saying is that if I try to divide B with A, I will get some quotient and 0 remainder. Which is the same thing as saying that B is a multiple of A. All of these are the same thing, right? So for example, 5 divides 10. 5 divides 5 also. 1 divides anything, correct? 1 will divide any natural number, etc. Does every natural number divide itself? Yes, right. So you see that when we are writing the symbol, at the back of the mind, this division, this div set is only operating, but for convenience we are using this notation. Can you think of any other situation where we use this kind of convenience notation? Same thing we kind of done with this kind of Cartesian product, but it's complicated also. So we use some notation. Any example like that? What about, let me take a different set. So this was the div set. Now let me consider the set. This is a new set. LT. And I'll just use some examples of the elements inside LT and you will guess what that set is. So 1, 3 is an element, 1, 5 is an element, 2, 10 is an element, 100, 101 is an element. Okay. But 101, 100 is not an element.
The first element has to be smaller than the.
So instead of writing, I can write 1, 3 belongs to LT. What do we write in normal 1? So you see, this is a short form of this, but we never told this in school. When you write 1 less than 3, what I'm actually wanting to say is that the ordered pair 1, 3 belongs to this interesting set. And now can you see more examples of this type? Always less than a set greater than, less than equal to is a different set. Do you understand? Because less than by the 1, 1 but I can create a new set LT, which is less than equal to. It should also have 1, 1, 2, 2, etc. So any element belonging to this set can be written as x2 less than equal to 3, for example.
Sir, I had a question.
Yes, go ahead.
Sir, I wanted to ask, when you were speaking about the div set, like if you say A divides B, like 5, say 10 divided by 5 gives you 2, right? But that operation of division doesn't happen in the set, right? So I'm sort of confused.
The operation doesn't happen in the set. That is correct. The operation is being done on the numbers, right? So
Okay.
the number 5 and 10 belongs to the set of natural numbers. So 5 belongs to 10 and 10 belongs to 10. So we are considering the order set 5, 10, which is a member of n cross n. So now the question is this a member of div or not? Because n cross n is a very big set, right? And div is a small subset of that.
Correct.
Your question fully, but I was just thinking of my idea. Okay. So you see, you can have many interesting sets like this. This is a pattern. So what mathematicians like to do is when you see a pattern, you give it some name. Like many years ago, when some mathematician observed that all triangles whose all 3 sides are equal, they have 60-degree angles always. So they gave it some name. What did they call it? So in the same way, this interesting subset keep coming again and again. So we should give it some name, and that name is the relation. So if you take any mathematics textbook after 12th standard, okay, first year BSc Math, second year, any such textbook if you go and pick up from any library, you'll always find that textbook has a chapter 0. And that chapter 0 always has these 3 topics in that. Okay. These 3 topics are always there in any such textbook. And there is a reason why that is there. Because these are the building blocks on which the entire mathematics is going to be constructed. Of the building. And that is why you have to study it. And what we just saw were examples of relations. In general, let us say you have any set X, given or F or A. So consider A cross A. So A cross A will have all pairs of elements, right? Which are both in A. And now consider some subset of that. Any subset of that ordered pair. Okay. So this R is called the relation. Did you understand the recipe? How to create a relation? Take a set, take its cross product with itself, and look at any elements. Out of that, any elements to bond links, like pattern. Like also, maybe strange. How can you pick any elements? They may not be interesting. So maybe we can take some examples. So let us consider A as the set. So how many elements does A have? 6. So how many elements in A cross A have? A cross A म्हणजे all pairs, right? 1, 1, 1, 2, 1, 3. असे सगळे pairs घ्यायचे. तर किती होतील? 36, right? Because every pair has 2 parts, first and second one. And there are 6 choices for the first element, 6 choices for the second element. So this will have 36. So with the सगळे देणार नाही. But out of that big set, I can choose any set I want. So suppose I choose the set. So this is the set I choose, which has 5 elements. 1, 2, 2, 3, 3, 4, 4, 5, 5. So do you see that first R is a subset of A cross A? Because every pair occurring here is composed of 2 elements, right? Both are there from set A. So there is no problem. So I say that R is a relation. And what do you think this relation is? Right? The first element, the second element is the consecutive one after the first element. That is the relation over here. So anything in the world you can imagine using relation this way. Okay? For example, in the class you may have many friends. Some of you may know each other, some of you don't know each other. So I can consider the set of all the people sitting in the classroom today. Okay, so let me call that set base. And then I take pairs of you. So I pick any random you and you. Okay, so both of you are inside one ordered pair. And now the question is, do you know each other or you don't know each other? Okay. So if you know each other, then you will be in that set. If you don't know, you will not be in that set. Obviously, one question is, what if I put the same person in both places? That can also happen, right? So, do I know myself or do I don't know myself? That is a difficult question. But you can answer it anyhow you want.
Sir,
Relation over A, just to indicate which set they are talking.
Us.
So we are going to study lots of
Sir.
relations in the coming days. Right now we just saw few examples like divisibility was one relation, less than greater than was a relation. Here is one interesting relation. So let me see if you spot what is the relation. I just show you some examples. By the way, yes.
can I ask it out before?
So if I let us say some parent is part of that relation, then again instead of writing A, comma B belongs to R, which is a very long sentence. So we prefer to write it in a shorthand by just saying A R B. So when I say A R B, same pattern. So you can put the symbol between the two objects. So here I'm putting that symbol R between the two objects. And what this means is A is related to B. So it can be the less than sign, it can be the divisibility sign, some other sign, whatever it is put between the two elements. Okay, that is the relation.
Sir,
So your homework is first try to find any interesting relation. Okay, doesn't have to be mathematics, maybe something in your home. Like, for example, you have many fans in the classroom and many switches on the board. So you can have the relation which fan is controlled by which switch, for example. Anything like that. You can talk. Any example that. Yes, somebody was asking something.
Yes, sir. I didn't understand what you mean by R is less than or equal to A cross A.
So you are talking about the less than operation.
No, sir. The relation that you said, I didn't understand what exactly it is.
Actually, can you speak up? I'm not able to hear you properly.
Hello, sir. Can you hear me better
Yes,
now?
go ahead.
Sir, I'm saying I did not understand what exactly relation are.
What exactly relation is?
Ah,
We saw examples of relations in the previous page. So, like divisibility was one relation. Less than, greater than, these are relations. So, relation is nothing but some property which may or may not be true if you give me any two elements. As simple as that. So, if you give me two elements from the set A, like for example, 1 and 2. Okay, so if somebody gives me 1 and 2, then does this relation R hold true for that pair or not? So in this case, the answer is yes, right? Because 1, 2 is in my set. But suppose somebody gives me 3 and 5, then does the relation R hold for 3 and 5? No, because that is not in my set. It is as simple as that.
Sir, I have a question.
But important is order matters. So once the relation is but 2 and 1, it is not 2, right? I cannot put 2 before 1. So 2, 1, this pair is not there in my set. Right? So this is not in my set. Okay? But everything else is there.
Sir,
So,
sir,
yes,
I have
go
a
ahead.
question. Yeah,
Yes.
sir. Why does relation have to be a subset of um
That is just
A
the
cross A?
definition of relation. I cannot
Oh, okay.
and why it has to be a subset. Because it has to be a subset of the cross product because relation is talking about two things at a time, right? So I have to
Okay.
take two things at a time and consider them as a pair. So that is why it has to be a subset of the. Yeah. For example, there can be a boring relation where everything is related to everything else. So this set A cross A is its own subset, right? So I can consider that itself as a relation. But that is not very interesting because everything is related to everything. त्याच्यामध्ये काहीच नाही. And there could be which is set. ज्याच्यामध्ये काहीच नाही. That is also not very interesting. So so let me see. Can you guess the relation between these two? So I'm just again consider and let me consider capital D is the subset of. So this capital D is the relation, and I have to give you some examples that what elements are in this capital D, and then you have to tell me if you can identify what it is. 8 and 13. 4, 4 belong here. 1, 6 belong. Anybody guess the relation? Anybody else? So after you guess the relation, can I keep track that everybody has guessed the relation? I'll keep writing examples. Maybe 100, 205. So somebody you think you have got the relation. So let me write one number and you tell me another number. So let me check if you understood. 61, what number should I write here? Anybody else? Any guess what is it? It doesn't have to be ascending, it can be descending also. So for example, 1024, 9. And scholarship exam is yes. Keep raising your hand, whoever guesses the rest. I'll keep writing examples until everybody has recognized it. Or until I get bored. whatever happens is fine. Okay, let's give a pattern. N at n plus 25, they will ground 3. Those who have understood relation, do you agree? N and n plus 25 is already pair. Any of this such any other pair which will always be in this set. Those who are guessing. Yes. X and x plus 5. Yes. So x and x plus 5 always belong to this. आता कळलं का? नाही x and x. बघा ना सगळ्या नंबरमध्ये कॉमन काय आहे? So, okay, can you separate again? Their difference is divisible by 5. Okay, correct. Any other way of expressing the same thing? Yes. Difference is multiple of 5. Okay, correct. Any other way of expressing the same thing? Which are all correct. Both of you are correct. Yes. What is factor of the difference? Nothing. Any other way of expressing the same thing?
They leave the same remainder when divided by 5.
We can write it as n comma n plus k 5k.
Remainder is if I divide by 5. Can you think of remainders? If I divide
So we
both
can-
numbers by 5, what is the remainder I'm getting? It will be the same remainder. So, can I create this new relation now? So, I am saying that x and y belong to D. It and only it. What? X and y give the same remainder. Have the same remainder. One dividing by 5. So it is such a long statement. X and y have the same remainder on dividing by 5. We are able to compress it in just a small symbol.
Sir, modulus x minus y, 5 divides modulus x minus y.
Yeah, 5 divides x minus 5 modulus x minus 5. All of them are also equivalent. But you see that how notation can help us to write a small, in a small space, a much complicated idea. Now, obviously, some of you are asking me, what is special in 5? I could have taken any factor. आता प्रत्येकाला वेगळा लेटर वापरून असेल का 5 ला D, 6 ला E, 7 ला F, 26 ला Z, 27 ला काय करायचं? So we need some way of doing this efficiently. We cannot have a different letter for every divisor. So maybe one idea is इथे आपण छोटासा जो डिवाइजर आहे तो इथे छोटासा लिखूया D5. Okay? So D5 is the set ज्याच्यामध्ये x and y are the same remainder with 5. So now you see that a divisor you can take and you get a different like D6 with for example. So can you anybody give an example of a pair in D6? 1 7, 1 13, like etc. In fact, any number and itself, right? X comma X. X comma X. Very good. So you see X comma X will be in all those because obviously X and X will be the same matter on dividing by. But do you see when एका मिनिटात suddenly we have created not one set or one relation, a whole family of relation, infinite relation. Take your budget and त्याच्या खाली तो divisor लावा. Get a difference. So the question is, are we just creating this set because आपल्याला वेळ जात नाहीये or काहीतरी interesting असेल तरच उपयोग आहे. So maybe there is something interesting, maybe not. We have to find out. So all of this is part of one topic called number theory. Have you heard of this topic, number theory? So number theory is what theory of numbers. Where you may have the question that I guess mathematics was all about numbers. So number theory is a वेगळं काय? Isn't all mathematics just number theory? No, geometry is different. Algebra is little bit different. Number theory is mostly about integers, natural numbers. Mostly focuses on those things. So these like GCD, LCM, remainders, all of these things come in number theory. So because I will not be taking all of your lectures, so next time onwards, Raj sir will take something else. But if you are interested in topics like this, you should read number theory. Okay? And if you want, I can suggest some books for you for reading on your own. But number theory is very important in everything that we do today. It is important in banking. It is important in finance. It is important in sports also. It is because prime numbers are very important. Many applications of but number theory two sets only. We started with set that's a relation philosopher usability. Then we defined general relation for D5, D6, and that is how we are approaching number theory. So anywhere you want to go, you can start from set theory and do that. That is why set theory is so important. So now what we are going to backtrack. Number theory because we don't have much time. So I'm going to come back to set theory and we'll take a different number. Set theory start from so number theory is one direction you want to go. Maybe you're interested in something else. So let's take a different direction. How about this? So I'll use that same check again. 1, 2, 3, 4, 5, 6. Can you think of a situation where you get this set 1, 2, 3, 4, 5, 6? Any example? Is it 1, 2, 3, 4, 5, 6 in real life. 0. But in real life, not mathematics. Right. When you throw dice, you get 1 to 6 number is na. So every time you throw a die, you're going to get one number out of this set, right? So the first question for you is, if you throw a die, how many possible answers will you get? 6. And do you see how to see that it is the number of elements in the set, right? So the number of elements in A will be exactly the number of, let us say, answer. What we should call it? What do we call it? Whatever number comes on top. Outcome. Number of outcomes. Throwing one die. That is the set. Suppose other people are 4 dice. One red die and a blue die. Or whatever colors I have. Let us say yellow die. So I have a yellow side and a green die. Some games have more than one die. It's through at the same time. So now how many outcomes you get? 26. Because yellow has 6 possibilities and green has 6 possibilities. And how do you think of that in terms of set? A cross A, because I can say temporarily let me say A1 is the set of all the yellow outputs and A2 is the set of the green output. The elements are the same, just don't make labels in it for my convenience. But both of them have 6 elements, correct? So total 36 possible, correct? Okay, then maybe the next question is, in how many of those possibilities, the first number will divide the second number? So you'll get some number over here and some number over here. So I am only looking for the possibilities where one number divides the other. So why divide 3? I want the answer of only this. So the answer will be less than 36. Of course, 20. Find out. For example, if both are 1, I am okay. If yellow is 1 and green is 2, I am okay. If yellow is 2 and green is 9, because it's the reverse. Right? So how many such cases are there where yellow divides?
14.
Yes, 19. Anybody wants the answer?
14. 14.
Yeah, so many of you are getting 14. And I guess you must have done it by directly counting, right? So, like, what are the possible values for the green die? 1, 2, 3, 4, 5, 6. And in every case, how many possibilities for the yellow die? Correct? So, if I write it properly over here. So, let me call them set 1, 2, 3, 4, 5, 6. Okay? So, set 1 is all the possibilities. But that this property has to be true, and the second element is 1, which is 1. So it can set S1. So similarly, I can define S2, S3, S4, S5, S6, right? So in every case, what I'm doing, I'm fixing the second element. If this is for S1, this is always 1. Correct? So I just had counting all the matching pairs. So we know how many factors 1 has, only 1, right? So therefore, I know that S1 has only 1 element. Similarly, I can define S2 exactly the same way. Only thing is I say G is 2. So now I'm counting elements of the type something comma. So how many such elements will I have? 2. Because 1 comma 2 and 2 comma 2, right? So S2 has 2 elements. And like that keep going. So how many elements each set has? What about S3? What is it? So how many elements each of them has? H3 will have also 2 elements. You will realize that any prime number will have 2 elements because prime number has only 2 factors, 1 and itself, right? So S3 will have 2 elements. S5 will also have 2 elements. S4, 3, right? 1, 2, and 4, right? And S6, 4. 1, 6, 2, 6, 3, 6, and 6. So if I add all of these together, I will get my answer. Correct? So the answer is 14, correct? But the question is, what are you doing in terms of the set? When you add the elements together, what are you doing to the set? S1, S2, S3, S6, add 6, set defined. So when you add the elements of the set like that, what are you doing to the set itself? Can you think of it like union? I can draw a Venn diagram of this. It will look something like this. So my entire A1 cross A2 is over here. Okay. So every pair is in this set. So it has all 36 possible values. But after that, I am interested in the properties or the ones which satisfy this property. So I am looking at maybe this is my set S1. And do you notice that set S1 and S2 cannot overlap because in S1 this is always 1 and in S2 this is always 2. So you cannot have an element which has both 1 and 2 in the right place, right? So therefore S1 and S2 they will be what we call disjoint. They have nothing in common. And S3 will also be like that. So you can think of this like patterns. So I learned that. And so if I want to count all the elements, I'll just add them together, correct? If I add all of them together, I'll get a total number, correct? And that is the answer 14. But the question is, can we always add like this? इथे का add करता आलो? Because there was nothing overlapping, correct? Imagine a different situation. So this problem has everybody understood? Okay, then let us go back to the original problem and ask a different question. So again, my now my question is, when you roll a die, you get a number. How many okay, so let my first answer be number of outcomes divisible by 2 with one single die. So how many possible? 3, right? 2, 4, 6. So this is simply 2 or 4 options. So the answer is 3. Then the number of possibilities divisible by 3.
Element of A is 6 or 8.
Divisible by 3 only 2, right? Either 3 or 6. And now if I ask the question, the number which is divisible by 2 or 3. Or 3. Even any one of 2 or 3 divides, it is okay for me. So what is the answer of that be? What is the answer? Numerical answer correct. 4, because this number will allow 2, 3, 4, and 6. 1 and 5 will not be allowed, right? So that's the answer 2 also. That's the answer 4. So if you just add 6 and this, I'll get 5. But here the answer is 4. So why cannot it don't add many goes to 6 common, right? So if I draw the Venn diagram of this, what will it look like? So the first set X go ahead and Y. So 6 is common to both the right? 6 is over here. And here you have 2 and 4 and 3 and 1 and 5 are outside. So therefore, I cannot just add them directly. The 5 is, but in that I'm this part 2 times, right? So I'm subtracting. Therefore, I get the answer. Here the example was small, so I can show it very easily with Venn diagram. But imagine the same question in a much more complicated case. Suppose I have a very big die which has 600 faces, not 6 faces, but 600 face die. And now I throw that 600 face die. So now you have said A doesn't have 6 elements, it has 600 elements. So 1, 8, 600. And now I have to ask the same question. X, first, how many out of 3 divisible by 2? So what will the answer of that be? 300. So here the answer is 300. And numbers will be like 2, 4, 6, etc. Right, all the way up to 6. Then how many outcomes divisible by 3? 200, because 600 divided by 3. And now how many outcomes divisible by 2 or 3?
400.
So if you again add 2 or 3, no, but 3 से plus 2 से तो 5 येईल. But now you have understood that maybe some elements will be common to both. So the common elements you have to remove it. So how many will be common? 100 common, because number divisible by 2 as well as 3 when they divisible by 6 will be counted 2 times. So our answer will have to be 300 plus 200 minus 9. That is 2. How can I make it complicated? Inside die. Okay, I can ask for an inside die. Let me ask you a different question now. Let us see if you have really understood this, and I'll give you some time, maybe 15-20 minutes to think and give me the answer now. So now I have again a 600 sided die. Whether it dies the singular is die, no? I think so. I think sometimes it is dies. So find the answer, find the number of outcomes that are divisible by 2 or 3 or 5. What are also outcomes? It can be divisible by 2 or 3 or 5, taking one of them, or more than one also. The number has to be by all 3 of them.
440.
How the secret is take your time, don't rush to the answer. This is a difficult question, I know, but that is why I'm giving you a chance to find out the answer first. Anybody online who already has the answer?
440.
Yes, sir.
I don't know the numerical answer, but just raise your hand so I know you have found the answer. Everybody is close to the answer, but everybody is close to the answer, but very few got the correct answer. So the first thing you have to do when you are asked a question like this, what is the first thing that you can do?
Sir, we can draw a Venn diagram.
We can draw a Venn diagram. We can. Anything else? What is the first thing that?
Include all of.
No, I asked the question for 600, but you don't have to start with that question. You can first solve a simpler question. त्याचा आन्सर तुम्हाला इझिली काउंट करता येईल. So what is the smallest question which you can 6, but 5 is पाहिजे ना. 30 and 60 both are located. So first consider let us say only 30 elements, 1, 2, 3, 4 up to 30. Together you can manually count how many elements have this property. And then whatever method you are applying, check if that method is also giving you the same answer. Then your method is correct. Otherwise, your method is wrong. So consider the simplest problem first. Simplest problem. So if I call this question 1, consider question 2. And everything is the same. So here you can simply list the number for the 30 and you can count. And what is the answer you're getting after counting? I think you should be getting 22, not 23. Okay. So if I just list the numbers, so here I list the only the numbers which are okay. So 2 is allowed, 3 is allowed, 4, 5, 6, 7 is allowed, 8, 9, So for 1 to 30 elements, I'm getting the answer as 20. But now the question is, can you find that answer without counting like this?
Yes. So the important question is, what has set theory got to do with this? इथे set theory का कुठे संबंध आला? If you are trying to solve this problem, so try to use the whatever you have done so far, right? So let us draw the Venn diagram. So let us say this is my universal set of vertical continuum. Okay, let me solve the vertical continuum problem. Now inside that, I will consider one set of all number divisible by 2. Okay, so let me call that set A. Set A. Then another set B will be there. Okay, so this is what my Venn diagram will look like. So can you give an example of a number which will be on the screen? Divisible by 30, right? I'm only going to 30. So in fact, 30 will be the only element over there, right? So here only we have. Now, what am I supposed to count? I want to count all the numbers which are divisible by 2 or 3 or 5. So which region of the graph I want to count? A union B union C. Any element there in any one of these set is okay with me, right? So any element in this whole region is fine here. This is the region I want to count. Right? So many of you are starting correct. Mistake. So what should be the first step over here? First, let us just take all the three given ABC. They add over here. Okay. So what I'm going to do is here I'm going to keep writing which region we have counted how many times. Because finally what we want to count everything inside this set and nothing outside. Correct? So let us say first I take the set A. Set A has how many elements? All the number divisible by 2. So 30 upon 2, 15. Correct? So I have counted everything in the set A once now. So we take it as one set. Now after that I will take set B. How many elements does set B have? 10, right? 30 divided by 3. So 10 elements. So in that I have counted all the elements in the green region by 1, correct? So I counted this one, this one, this one. So you see already it's a double counting. This part is counted times. But it continues. After that, what do we do? See, how many elements does C have? 30 divided by 5, 6 elements. So we are counting all of these ones. So now do you see what has happened? These regions, these are outside regions we wanted to count once. You have correctly counted. But the regions inside which are overlapping. So we have to remove the original region. So how do we start the removing? Let us first remove the region which is common to yellow and green. So common to yellow and green, this part, correct? So minus. So common मध्ये काय intersection, correct? A intersection B. So which means I am looking for a number which is divisible by 2 and divisible by 3. And divisible by 6. So after 30 upon 6, 5, correct? So now I'm subtracting. So I'm subtracting, I should cancel a 1, correct? So let me cancel a 1. क्या minus 1 लिखूं का? I'll write minus 1. ये ज़्यादा नहीं है, बड़ा है, minus. So now if you see this region, what is the total count of this region now? 1. But don't add केलं एकदा subtract केलं. So this region is now correctly accounted for. We have to do the same for other regions also. So what should I do next now? Let us say yellow and pink. When the A intersection C. How many elements will that have? 2 and 6 by 10. So 3 elements. And so again I have to subtract 1 from here. I say the lava नहीं है. See this region, something because we have done plus 2 minus 1. And now finally this region also, right? Green and pink are common region. So that also I have to stop, right? So that is B intersection C. And how many elements should that have? B and C. So divisible by 3 and divisible by 5. 15. So how many elements? Only 2, right? 30 divided by 15. And so I subtract 1 from this region. So now you see this region is also taken care of. So all regions are taken care of now. So it's hard to see, but can you imagine how many times you have added 1 and subtracted 1? Every time. Because any other set will take that common region always be there. So we have added it 3 times, subtracted it. So effectively we are not counting the extra region at all. So we have to count that element once. And एकच आहे ना जो 2 3 5 नी डिव्हिजिबल आहे असा एकच एलिमेंट आहे राईट सो दॅट वी हॅव टू ऍड अगेन करा टोटल किती आहे and when we counted you also got the answer 22 so if you are using two methods and getting the same answer hopefully you are on the right track so करू शकता असं कधीतरी but mostly it should be on the right track so I know maybe this is a bit complicated to hear for the first time but this is your homework go home and understand it properly create your own small problems like this right now I took 2 3 5 you can change the number take 3 5 7 you get a different problem do the counting manually verify with this method and see if you're getting the same answer okay. But you see again how set theory is used for counting something like that but complicated counting करायला पण set theory चा वापर करू शकतो so this is a different topic do you know what the name of this topic is anybody has heard this
Combinatrix.
Inclusion exclusion principle.
is the name of this theorem, but what is the subject called?
Combinatrix.
See, I have a difficult problem that I only have 2 hours, and in that I want to introduce you to a lot of things. So I have to go a little bit fast, unfortunately. But if you take your time, understand all of this properly, you will see how powerful this thing is. And then you start to see applications of this in various situations. For example, I can ask you the question, take, you know what is coprime? When the acid is 1, we call it coprime, right? So if you take a very large number, like 1000, right? Look at all the numbers, 1, 2, 3, 4, up to 1000. And out of those, some number will be coprime to 1000 and some will not be coprime. And so if I ask you the question, how many coprime numbers are there? With 1000. So that is the question which you can answer with this kind of question. And any such question you can answer with set theory. This is combinatory. So far you have studied number theory, combinatory. Let us come back to set theory. Can we take some other different approach? And we have only half an hour left, so I'll maybe want to go to some further. This is a very interesting. Maybe some of you already know this puzzle. Then don't disclose the answer. Okay, let us think. But so there is a kingdom, you can say. Bahubali like dynasty. There is a king and king has prisoners. Many prisoners. There's going to be a big event, big party for all the major ministers and everybody is going to come tomorrow. And for that party, the king has ordered 1000 bottles of water. Okay? And he has almost 24 hours from today that party is going to take place. And some spy comes and tells the king that out of those 1000 bottles, one of them is poison. And the king has only 24 hours to figure out which bottle is the poison bottle. And it's a very powerful poison. Only one drop is enough to kill anybody. But it is a powerful but slow acting poison. So it takes 24 hours for the person to die. But definitely with one drop. So now the king has a big question. He has to find out which of that bottle is problematic. Now in this you have to take some creative license because students give all kinds of answers that where does the king doesn't simply buy another 1000 bottles of water. The king should be able to afford that. But okay, for water constraint, there is a strike, whatever extra constraint wants to add. He has to work with those 1000 bottles. Thankfully, he has 1000 prisoners with him, right? So what we can do, take prisoner 1, bottle 1, give him 1 drop. Prisoner 2, bottle 2, give him 1 drop. Prisoner 1000, bottle 1000, give him 1 drop. And then wait for 24 hours. Let us say prisoner number 513 dies. So now I know that bottle number 513 was the problem. Correct? Fine.
Sir, can you repeat? Your voice was breaking.
So you understood the problem that there are 1,000 bottles. One of them is poison, and you have to identify that poison bottle. And so we have to give one drop to each prisoner and see who reacts to that bottle. And so we require 1,000 prisoners to solve this problem. But now think, if you are in their position, whoever is the king or queen, that you want to solve this problem. Can you do it with less than 1,000 prisoners? For example, at least you can say I can do it 999 prisoners. Why? If nobody dies, then the 1,000 bottle was the problem. No? So you saved at least one prisoner's life. But can you do better? 999, 998. कितने खाली जाता है?
10.
If somebody already knows the answer, then don't reveal. Okay, first, how much you heard of this problem before? Nobody. Maybe somebody online has heard of this problem. So we'll call this 92,000 bottles. I have to find one bottle out of 1,000 bottles. How many prisoners will are required to this? So we can only one time. So you will think it requires 1,000. I want to find that one bottle. Okay, somebody has a creative solution. Let us take 500 prisoners, and each prisoner will give 2 bottles. Okay, and so whoever dies, I know that one of those 2 bottles has the problem. But so this solution is let us throw away both of those bottles. But I am a very particular thing. I want to find that one bottle. Take 500 and one prisoner, and take one prisoner and give them 500 2 prisoners. 2 other prisoners, give them full guard to the bottle. That's a nice idea. Did you understand the solution? What is saying is like this. Let us say alcohol bottle 1. If you want to okay, bottle 3, bottle 4 is going to etc. What is the last bottle? Bottle 999 and bottle 1,000 is given to prisoner 500. In this situation, what happens? Whichever prisoner dies, one of those 2 bottles is the problem. And after that, if you start doing the second round, then it will be too late for the party. While waiting for the second round to start, after the first result has come. So, but are you going to do this trials after the first round has completed? Okay. But in your result, you are going to do bottle 3 and bottle 4 and something else. Can you exactly work on the details and how many prisoners will requiring us? So I was afraid of that. So his solution is very clever. What you do is you take only one prisoner and you give him one drop of each bottle, but exactly one after 1 second. So if he dies after 13 seconds, then bottle number 13 is the problem. But there you are assuming that that exact 24 hours is there. So give me some freedom that it is not exactly 24 hours, but certainly you don't have enough time for to go through trials. That is what I will say. Can it will suggest some small modification to this so that on the first day itself the problem will be over? Up to this point, it is okay. We'll identify the 2 bottles. Let us say, for example, that bottle 9 and 10 was given to prisoner 5. Right? Let us say prisoner 5 dies. So now you know that bottle 9 or bottle 10 was the problem. But now There itself can you finish the problem? I will wait for one more day.
Sir,
Yes.
in how much time does the poison start acting?
Not less than 12 hours and not more than 24 hours. So therefore, you don't have a chance second trial. You don't have second chance. Now, how much time it will take, all that doesn't matter.
Okay.
44% bottle 1, 3 and 2.
Okay. But can you something like that, but it should be random. The criteria systematic पाहिजे. Yes. We can give the but then for 1,000 bottles you require 1,000 prisoners, right? So you're doing 1, 2, 2, 3, 3, 4, 4, 5. So that will go to 999, 1,000. You require 1,000 prisoners. Yes, but 3,000 bottles, how many such prisoners will you require? Because you are grouping into groups of 25, 25, but out of that, which is the poison bottle? I didn't understand. नहीं, don't try to come with your own solution. First, या solution मध्ये एक छोटासा change केला तर work होणार आहे. मी सांगतो तुम्हाला. Just one small change.
Sir, can you repeat
You
this
require
solution
just
on the
one more
board?
prisoner. Sorry, Ariman.
Sir, yeah, sir, I lost my net in the middle. Can you just repeat what you've done on the board?
Sorry, I'm not able to hear you.
Sir, I'm just saying, can you repeat what you've done on the board? I'd lost net in the middle.
So what I've written on the board is bottle and prisoner, 3 and 4 is going to prisoner to exit, right? So the change is
So you're giving,
don't change. So the hint I'm giving you, there is one more prisoner you are allowed to use, prisoner number 501. That one prisoner you have to use very, very cleverly. What will you do that prisoner?
sir, so you're giving 2 bottles per prisoner, right?
What if we took this
Sir,
entire
we
row
can give
if we give this entire row to this prisoner at the same time, we have to give only one drop. असं नाही की एका बॉटलमध्ये जास्त ड्रॉप घेऊ शकतो. So from this bottle, I'll give one drop to P1 and one to 501. From this bottle, I'll give one drop to P2 and one to 501. And now suppose P5 dies. What will happen?
Sir,
Depending on whether this person dies or not, we have the answer. If this person also dies, then which of the bottle will die? If P5 dies but this person does not die, then
sir,
yes.
instead of like giving 2 bottles, if we give 3 3 drops of each bottle to each person, and such that the sequence of the bottles is random, so we can understand, like, assume there's 6 bottles and you give it to 2 people. The first person gets 1, 2, 3, and the second person gets 4, 3, 4, 5. And if the both of them die, then it's gonna be the third bottle.
Yes, something like that. But I think you have the right idea, but how much can you reduce the number of prisoners required using that? But you see this kind of table method, you make a table where all the rows you give to one prisoner and all the columns you give to different prisoner. And that combination of which column and which row dies, that will give the answer. I think so here I've created a table of 500 cross 2. But you can prepare a table of any dimension. So what other table can you do? 100. We have 1,000. So let us consider a new table where I take bottle 1, bottle 2, up to bottle 10. Okay, this is my first row. This row will be bottle 11 to bottle 20. Etc. Last row will be bottle 9 and bottle 1,000. Okay, so I have prepared this grid of bottles. And what should I do now? How many bits I require in this method? 110. Because what will I do? I take the entire first row and give one drop to first prisoner, right? One drop of each bottle will go to prisoner 1. Second entire row prisoner 2. Last row prisoner 1,000. So one of those 100 prisoners will die, and that will tell me which row the problem is. And then what should I do? You can also take the column. You can also take the column at the same time. Don't have to wait for day 2. So at the same time, I will take the first column. Give that to prisoner 101. And this column I give to prisoner 110. So what will happen? Exactly one person here will die, and one person here will die. And where is that intersects, that is your bottom. So now how many prisoners you require? 110. So you are already such a good ruler. From 1,000 prisoners, you have brought it down to only 110 prisoners. Yeah, prisoner, but still the public is very happy with you. Like you are doing such a good. So can you become even better now? 65. Okay. Interesting idea. So close square root of 1,000 is roughly 30 something. So maybe you can make a neighbor of 32 from 32. And that will give you 64 prisoners. Yes, that is correct. Can you do even better? Can you think a little bit even more outside the box? 11. Cube now. See, first we had all 1,000 prisoners which are standing in one line. From there we got them to this 2-dimensional table. And now there is a row and column. What is the next step of the row and column? 3-dimension. So for example, why don't we do this? 1,000 is what? 10. So what will I do now? Row, column, and I don't know what to call it. So arrange the prisoners in a 10 cross 10 cross 10. They have to stand on each other's shoulders, but okay, allow that for at the moment. Okay. So the first, it will look like a cube, right? Sorry, the prisoners don't have to stand, the bottles have to stand. Prisoners are on one side. So, the first top row of that cube contains 100 bottles, correct? So, all those 100 bottles are given to prisoner 1. So, like that, I'm slicing my cube. I'll get 10 slices like this, correct? Because my cube is 10 cross 10 cross 10. So, I have 10 prisoners standing here, and each prisoner, let's say P5. P5 is going to take one drop of this slice, the 5th slice. Okay. Because of my and my drawing is not very good. Then what to do? You can slice the cube in a different direction. Asa vertical slices. Asa slice मारू शकतो. So here we require prisoner P11 to P20. So where this green slice and yellow slice intersect, like that row. So we require one more slice in the transverse direction. Like this. Front to back slices. And there will be 10 prisoners like that. So there will be one green prisoner who will die, one yellow prisoner, and one pink prisoner. And then the intersection point, that is your water. So now how many prisoners will require? That is where I'll give you for now. because you can do even better, but I am not going to tell you the answer. So imagine first we start with 1,000 prisoners, they're down to 30 prisoners, and they're going to keep reducing. But if you think about it, this is all set theory. This is all set theory. Because what was prisoner one? Prisoner one is nothing but the set of all the bottles in that first set. So I'm just taking divided by universal set into various sets. So P5 is one set. Maybe let's say here P 16 dice, and maybe on the pink dice P 21 dice. So I'm going to take intersection of P5, intersection of P16, intersection P21. The only element which is common to all those three sets is my bottle, poison bottle. So if you think of this in terms of set theory, you will see that you can get the answer faster.
Sir, sir,
By the way, I have many such puzzles. What I can do is I can give a PDF which has maybe 10, 20, 30 such puzzles. And each puzzle has some different answer. Not all of them can be done. Say, okay, but many such ideas are there. Yes, somebody online.
yes, sir, I had a question. So in this arrangement, one prisoner will drink from 100 bottles, right?
Yeah, one prisoner will drink from 100. That's correct.
Okay.
So we have 10 more minutes. Let me just leave you with some problems. And again, just as last time, please send me your problem. Like whatever you solve, send it to me because I am interested in going through your responses. I'm getting a lot of information that what you are understanding, what you are not understanding, the very difficulty. All these things are important for me to understand. And that feedback will help Raj sir also, who is going to take your lectures from next time. So you have to communicate with us so that we can help you. Okay. What is I don't know what the problem is that area. We just copy these two questions, then I'll erase the board and write two more.
I have one more question. Intersection of that. Oh, that's it. Let me briefly explain the last problem because I actually want to cover this, but I ran out of time. What is this set talking about? I'll just draw the Venn diagram of this to explain. So I'll just draw the Venn diagram of the left hand side. Okay. So what is that looking like? So first A intersection B dash. So what does that mean? I want all elements which are inside A but not in B. Correct? So which part of this should I highlight? So the left half, right? I will not because of the left, the middle part. Basically this part. Correct? This is this part. And similarly, what about the second bracket? B intersection A dash. All the elements belonging in B but not in A. So which part is that? This right. So remember that union is all the elements which are in A or B. Correct? Union is all the elements which are in A or B. So what is this yellow set? Yes, that is what the right hand side is saying. If you put it in words, the yellow set is all the elements which are in A, XOR B. Remember XOR, exclusive OR, where both statements are not true at the same time. So if you see this yellow region is where element is in A or is element is in B, but not both true at the same time. So this is the exclusive OR that you were talking about last time. So we said that there are two kinds of OR, right? Inclusive OR and exclusive OR. So this is actually A XOR B. So that is what you have to find. And you see, obviously, in the diagram also it looks like the RHS is going to be true. Because what is the RHS? You take A union B, which is the entire set. But you don't want the elements which are in A intersection. It is subtract the middle part. So now intuitively this makes sense, but you have to prove
property like L and R. So prove it then. Okay, so that's all. Thank you. So next thing on what I think that's a bit of something completely different. But you can always stay in touch with me. Or anything you discover, any problem you solve, you can always send me. So those were online. I am talking of. Thank you. Bye.
Thank you, sir.
Thank you, sir.
आपलं कसं American